In this video, we're going to do more integration by parts examples. There is a video 1 on the channel that has simpler examples. This video is going to show examples that are a little bit out of the ordinary, but that you still may see. So for this first one, let's start with, we need to choose u and dv. If we need to, let's revisit our integration by parts formula. We start with a problem that has a u and a dv in it. So for this example, let's make u equal to x squared, dv equal to sine of pi x dx. Now, in the right side of my integration by parts formula, I have u, so we've said u is x squared, but I need v, which means I need to integrate both sides of my dv formula to give me v. In the formula, I also need du, which means I need to take the derivative of both sides of my u equation. So let's do that next. Du is going to be 2x, and then after I multiply dx on both sides, I get 2x dx. For integrating the dv equation, I do need to use u sub, so let's make u equal to let's make u equal to pi x. Du would be pi dx, so I need a pi dx, which means I need a 1 over pi out front. The integral of sine is negative cosine, so I'm going to make this negative 1 over pi. And I'm going to have cosine. After substituting back in for u, it's going to be cosine of pi x. Now I want u times v and then minus the integral of v du. That's my formula. So u times v is negative 1 over pi x squared cosine of pi x. And then I have minus the integral of v du. So I have negative 1 over pi cosine of pi x times 2x dx. Now, what makes this problem a little bit more complicated is normally when we get to this second step, I can integrate this integral, and we still can, but notice I'm going to have to use integration by parts a second time. So I'm going to clean it up a little bit. I'm going to move it down here. Okay, I have two negatives, so I'm going to have a positive. I'm going to pull out the 2 and the 1 over pi. So I'm going to get plus 2 over pi. And then cosine of pi x times x dx. So for my second integration by parts, I'm going to make u equal to x, dv equal to cosine of pi x. Same process as before, I want du, that's going to equal dx. And then when I integrate, this should be cosine of pi x dx. When I integrate both sides over here, I need to use u sub again, same u as before. So I need pi dx, which means I need a 1 over pi out front. So I get v equals 1 over pi. Integral of cosine is positive sine. So I end up with sine of pi x with the 1 over pi out front. All right, so for my next line of work, I'm going to copy this same first term. And then I have plus 2 over pi times my integration by parts formula. So I have u times v minus the integral of v du. And at this step, now I can integrate this integral, and I don't need to do integration by parts again. Now I can just do a regular u sub. So I'm going to copy that first term again. And I'm going to distribute this 2 over pi. So I get plus 2 over pi squared x sine of pi x. And for the integral, I'm going to pull out the 1 over pi. So I'm going to have minus 2 over pi squared. And then for this integral, we need u sub again. So I need pi, which means I need another 1 over pi. So this is actually going to be minus 2 over pi cubed. And let's see, the integral of sine is negative cosine. So this negative, I'm going to make positive. I have cosine of pi x plus c. And there is our answer. All right, so first, different type, we could do integration by parts multiple times in a problem. So this is an example of us doing it twice. For our second example, we did the integral of natural log of x in the previous video, so go check that out if that's what you would like. For this one, we can do parts with it the way it is, but sometimes it's easier to sub in for like a 2x plus 1. Now when I do parts, I'm going to be using the letters u and v, so let's just choose any other letter. I might just do like w. So we are doing u sub at the beginning, but I'm going to make it, let's write it differently. I am doing u sub at the beginning, but let's just use w. So I'm going to say let w equal 2x plus 1. dw is going to be 2 dx. So I'm going to make this a 2, which means I need a 1/2 out front. So I'm going to rewrite this in terms of w. And now it's going to be a lot easier to work with the integral in terms of w. So let's do our integration by parts now. I'm going to make u equal to natural log of w. I'm going to make dv equal to dw. So that means du is 1 over w dw, and v is w. Let's do our formula. I have 1/2 times my formula. So I have u times v, so w natural log of w, minus the integral of w times 1 over w dw. All right, let's simplify our integral, and I'm also going to distribute the 1/2. So I have 1/2 natural log of w minus 1/2. W times 1 over w is just 1, so I get the integral of dw. So I have 1/2 w natural log of w minus 1/2 integral of dw is just w plus c. Last step is we don't want our answer to be in terms of w. The original problem was in terms of x. So last step is to replace all my w's with 2x plus 1. So let's do that. 1/2 times 2x plus 1, natural log of 2x plus 1, minus 1/2 times 2x plus 1, plus c. And we can distribute and simplify further, but I don't feel that that's necessary. So we're going to make that our answer. So this special case was sometimes it's easy to do a u sub before you do integration by parts, and that just makes your problem a little bit simpler to do. We have one more example for this video. So this is another integration by parts example. For this one, let's make u equal to sine of 3 theta and dv equal to e to the 2 theta d theta. Du, derivative of sine is cosine. And then keep in mind we are going to have to chain rule, so times 3 because that's the derivative of 3 theta. I want to integrate both sides of dv. We do need u sub. U is 2 theta. Du is 2 d theta. So that means I need a 1/2 out front. The integral of e to the u is just e to the u. And when I plug my 2 theta back in, I get 1/2 e to the 2 theta. All right, let's do our formula. I have u times v. So I have 1/2 e to the 2 theta sine of 3 theta minus the integral of v du. So let's see, this is going to be 3/2 e to the 2 theta cosine of 3 theta d theta. Now I want you to notice, just like our first problem, we are going to have to do parts another time. So let's do it. I'm going to make it look a little easier though. I'm going to bring the 3/2 out front, is what I mean by that. Okay, so let's do parts again just for this integral. So I'm going to choose, same thing, I'm going to make my trig cosine of 3 theta my u. I'm going to make dv equal to e to the 2 theta d theta. That makes du, derivative of cosine is negative sine, and we are going to have to chain rule again. So I have negative 3 sine of 3 theta. When I integrate both sides of the dv equation, I get v equals, notice this is a repeat of what we did in the first integration by parts, so I'm just going to copy the same answer, the same v. So let's write it out again. And then I have minus 3/2 times my integration by parts. So I'm going to have 1/2 e to the 2 theta cosine of 3 theta minus, in my integral, I have negative 3/2 e to the 2 theta sine of 3 theta d theta. Let's make this look a little nicer. Simplify a little bit with our fractions. I'm going to distribute the 3/2. So I have minus 3/4 e to the 2 theta cosine of 3 theta. And then let's see, I'm going to have for the second term a negative, and a negative. So that's going to be a negative. 3/2 times 3/2 is 9/4. And then in my integral, e to the 2 theta sine of 3 theta d theta. Now at this point, you might be thinking, this isn't getting us anywhere. And it isn't, but it also is. So I want you to notice I have e to the 2 theta sine of 3 theta right here. And this is the integral that we started with. So I'm going to move our work over a little bit. So at this point, we are saying, and I'm going to copy this, we are saying that my original integral equals all this stuff that includes the integral. So we called this a loop when I learned it way back when, but what you want to do at this point is I can add 9/4 e to the 2 theta sine of 3 theta d theta to both sides of my equation. And then I can solve for my integral, and that'll give me my answer. So keep in mind that this is 1, so 1 plus 9/4 is going to be 13/4. And I'm just going to copy everything else down. Okay, now I don't want to know what 13/4 times my problem equals. I want to isolate my original integral. So now I'm going to multiply both sides of the equation by 4/13. So I'm going to multiply both of these terms by 4/13. So that's going to tell me that my integral equals, simplify, this is going to be a 2/13 minus my 4's cancel, 3/13 e to the 2 theta. And then it is an indefinite integral at the beginning, so don't forget your plus c at the end. And that is your answer. So sometimes when you have to integrate by parts, it's usually twice. You'll notice that you get your original problem as part of your work. When that happens, add it to the other side of the equation and then solve for the integral that you want to solve for. So that is our last example of integration by parts examples that are a little different.